Done. All right. Welcome everyone to the 2020 APEC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 124 different speakers over 11 days. Also, it will cover sessions on 4 different languages. Please remember to register to as many sessions you can, and all sessions will be available to replay as many times you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, running Oracle upgrades on Docker. Please feel free to write questions at any time during the session and using the Q&A tab of Zoom webinar. And Sean, this case, the speaker, will be answered them at the end of the session. If any issues during the presentation, please feel free to contact me at any time on the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session called Running Oracle Upgrades on Docker. Thank you, my friend. It's all yours.
All right, thank you so much. I hope it's an amazing session, at least. I appreciate the introduction. Thank you for inviting me to present this session. And let's dig in here. What do you say? Real briefly about me, I have been working with Oracle Technologies for about 25 years now. And I'm on the board of the Utah Oracle User Group here in the US, and then also the RAC Special Interest Group. I've presented it to Open World and Collaborate and regional user groups throughout the US and Canada. I'm coming to you from Idaho in the US, which is kind of up in the upper left-hand corner, close to Canada, sort of, kind of, I suppose. I'm a principal consultant with Viscosity North America. Viscosity is a full-service Oracle Platinum Partner and 2019 Oracle Database Appliance Partner of the Year. And in my role, I help customers with RAC, with the maximum availability architectures, with engineered systems like Exadata and Database Appliance. And I work a lot with Autonomous Health Framework, formerly Trace File Analyzer. I have a pretty strong background as an operational DBA and database reliability engineer. So I tend to automate a lot of things, and particularly when it comes to things like upgrades, migrations, cloud implementations, that sort of thing. I am an Oracle ACE, and if you are not familiar with the ACE program, it recognizes members of the Oracle community for their technical and other contributions to Oracle technologies. So if you or someone you know is active as a presenter, as a blogger, or if they're working behind the scenes in a user group such as this, to put on an event like this, I encourage you to nominate them or nominate yourself. I know that there is a monumental amount of work that goes into putting on an event such as this, even if it's a virtual event. For those that are not already familiar or completely comfortable with Docker, I want to take one slide to just cover some of the topics and terminology that we'll use in the presentation, just so that you've got something to go on. You don't have to be deeply proficient with Docker to take advantage of what I'm going to show you here today, but it is a technical presentation, and so it's going to benefit you to have sort of some boundaries or some ground rules around which you'll understand the terminology. So the first one is the image. Images in Docker are file systems. They'll contain all of the directories and the files that you need to run something. So a Docker image for an Oracle database is going to include the Oracle base, the Oracle home, an inventory, plus all of the binaries, all of the libraries and dependencies and so forth that Oracle needs to run. If you're familiar with Vagrant, a Docker image is sort of like a box. It's a self-contained set of files with everything you need to run something. And from an image, we start an image or run an image as a container. And all that a container in Docker is a process running on a system. It's a contained, isolated process that we run on a machine. It uses that image as its foundational file system. And so that image is static. It's just that set of files. We never end up changing the image. When we run it and we create a container, that container is the active process that does all of the work and that we can interact with. The next thing is a Docker file. A Docker file is just a set of instructions or directions. It tells Docker how to create an image. So we use the Docker file to build that image, that set of directories, that file system that we're going to use later on to run a container. When we issue the Docker build command, Docker is going to read that Docker file and follow a set of instructions step by step to create and build that image, to put all those files and directories that we need together. There are a number of different operations that we can include or we can call inside of a Docker file, but I want to highlight 4 here that are going to be important for us today: from, copy, run, and env or environment. From tells Docker that we want to use an existing image as the basis for building something. So we're not building something completely from scratch. We'll typically do from maybe an existing Linux distribution. So from Oracle Linux 7, something like that. Docker is then going to pull or load that image into its context, into its little memory area. And from there, it's going to add, delete things, manipulate that base image to create our ultimate product. Every step that the build process operates on, it's going to run that original image as a new container so that we can, or so that Docker can modify and ultimately create that final image that we're going to work from. So that's the from command. We're just telling it we want to start with this. Copy does just what you might think. It copies things. It copies files or whole directories into an image that we're building. So we can copy things from a local machine. So I can have my Docker file running in my local file system, or I can copy things out of an existing image if I'd like. And that's going to become important in what we do a little bit later. The next is the run command. And like you might expect, run runs things. It runs commands that we use to modify our image. Remember that our build process is running a container, and that container is going to have a file system. It's going to have binaries and libraries and so forth. So we can do all sorts of things with that existing set of binaries and files and whatnot that we have in our image build process. So we can run make, we can do CP and MV and makedir and create users and so forth. We can also run shell scripts. So we can copy a shell script of our own design into an image if we want, and then run that. Or we can run a script like run installer to install our Oracle database. And then the final part of the Docker file is the env command. It sets environment variables that are going to be part of our final image. So we can use env to set our Oracle home, for example. We can even set a default Oracle SID if we like. And then those values are going to be saved into the final image. We have the option, though, when we run a container to override those environment variables if we want. So that covers the Docker file command. Docker build, it reads that Docker file and executes every step, starts a container to make modifications and so forth. And when the build command completes, if it completes successfully, we'll have a brand new image from which to work. And then the last couple of commands here are Docker run. Docker run tells Docker that we want to take an image and run it as a container. So it'll start a process on our machine, and that's what starts or creates a container for us. And then Docker exec and Docker attach are a couple of ways for accessing our container and attaching ourselves to it so that we can interact with it and see what's happening within it, kind of like SSHing into another machine or doing vagrant SSH into a vagrant box, things like that. And then finally, the last thing I want to talk about here is that Oracle maintains a GitHub repository of open source Docker image build files. So these are all the scripts that build images for us. So we don't have to do any of the heavy lifting or genius work of building images ourselves. It's all set out there for it. for us to work with. And these files here at this github.com/oracle/docker images are going to be the framework around which what I'm talking about today, what all of that is built. But before we dive into the technical content, I want to touch on why you might want to consider using Docker as part of your upgrade strategy. And for that, I like to compare database migrations and upgrades to the World Cup of soccer or to the Olympics, because they have a lot in common when you think about it. They're both really high stakes events and they occur infrequently. Hopefully you aren't doing upgrades every year. And the event and the participants are under this really unique pressure and intense scrutiny, because you've got one chance to get it right and you've got this huge audience looking on. And they also tend to bring out experts in air quotes, I'll say. Here in the US, every time the Winter Olympics come on, we go, for some reason, crazy about curling. People will tune in at 2 and 3 o'clock in the morning to watch curling, and they're suddenly authorities on ice conditions. 3 years out of the year, they don't, or 3 years out of the cycle, they don't care anything about curling. But when curling's on, they can tell you everything you want to know about ice. And that's the equivalent in the upgrade world or the database management world of those cubicle surfers that you may know who stop by to let you know about how they were Googling this hidden parameter that you might find useful when you're working on your upgrade. On a serious note, upgrades and the Olympics both have very high expectations for success, and that high bar can eclipse an otherwise exceptional performance. If you miss it by just a little bit, we end up only remembering the failure. So what do we as database professionals do to prepare for our upgrades? And the answer to that is to treat it like an athletic event, by training for it, by practicing. If you look at elite athletes and elite teams, top level teams, they drill and they perfect fundamental skills until they're second nature. And this is where Docker comes into the equation, because it serves as our gym, as our practice field, if you will. It's fairly ubiquitous in many enterprises, but I find it still a little underutilized, or very underutilized, in the database space. So if you're not a convert, let me make a quick case on Docker for you. For one thing, it's free. And it's also fairly fast and easy to learn. There are a number of resources available to help you get up to speed pretty rapidly if you'd like. There's a good chance that you've got people in-house within your organization, maybe development teams or operations teams, that are already using Docker and who are familiar with it and can assist you with this. And most major cities have meetup groups that may discuss on Docker, if not exclusively, then partially. And there's a lot of training online, including videos on YouTube. I have a YouTube channel and I've got some Docker videos on there for you. Another attractive thing about Docker is it is a portable utility. The containers are part of an open standard. And so the images that I build on my Mac or on my Linux lab machine, I can take those images and I can ship them to anyone, anywhere in the world. And if they're using a machine that has Docker on it or any kind of similar software that uses the same Open Container Initiative standard, my image will run on their machine exactly the same way as it does on mine. We can add these images or the instructions for building the images to a private repository. We can distribute them within an organization, and we can manage them all under version control, because Docker files and the scripts and so forth that we put into them are simply code. Docker is also very light on system resources as well. So while I can maybe get 3 or 4 virtual machine databases running on my laptop, it's not going to be happy about it. But I have had 9 Oracle database instances running simultaneously in Docker on that same laptop. And they all survived a cross-country flight on battery power alone. So pretty light on resources. So why is all of this important to us? Well, we don't want to test upgrades in production. But Sean, you say, we're a sophisticated shop. We have multiple development, test, QA systems, whatnot. We've got stage and unit test and validation environments. Our DBA team even has a completely separate set of database hosts where all we do is validate backups on a weekly basis. And every month we do failover drills like we should. We would never, ever be testing in production like you're suggesting. We would, of course, start in our development environment. And to that, I say, you're testing in production because every environment in your enterprise is somebody's production. It may not be production, but dev is production for your devs, and QA is production for your QA team, and so forth. And chances are probably pretty good that your employer didn't purchase and provision a bunch of infrastructure, especially database infrastructure, so that it could sit idle waiting for you to come along and practice upgrades. We want it all to work. And if you can't take an environment and break it for an unspecified, extended period of time without any sort of consequences or backlash, it's not really a place where you have the freedom or the luxury to truly test out an upgrade. Which is why Docker is great for this sort of work, because you can work all the details out, all of those weird kinks and whatnot, in a private Docker container or in a team space that doesn't have very high provisioning costs, where it doesn't impact your other internal users. You have the freedom to build it and tweak it and break it and tear it apart and blow it up and experiment and all those wonderful things without having to coordinate maintenance windows or fit anything into anybody else's schedule, because a Docker environment is, or can be, entirely yours to work with. So what is it that we can accomplish in Docker when it comes to upgrades? Well, first, we can make decisions about upgrade methods. So if you want to try out the difference between Database Upgrade Assistant and Auto Upgrade, you can do that in Docker, where you might not have that flexibility in a development environment, say. You can work out your procedures, the steps, the order, and so forth, and refine and build up a set of documentation that's going to be robust and reliable and well-tested and so forth. You can start building automation into the process. So where you only have a limited number of pre-production environments where you can fine-tune that automation, with Docker, you can just do it repeatedly over and over and over again until you have it very highly refined and very accurately working. You can, of course, validate all of your monitoring and metrics. And when it comes to how that new database environment behaves, it's a wonderful place to figure all of that out. We'll take the optimizer. That's the prime example. When you upgrade a database, if you're, for example, moving from 11G, say, to 19C, I don't think that I can count the number of optimizer changes alone that exist in that delta. So with all of that new feature and functionality, learning how to work with that and how the database behaves with an existing set of queries and so forth in that new environment is really important for us, because we want to be able to recognize and react to those behavioral differences when we get into our upper environments, into our UAT and our production environments, so that if something does start going wrong, we're able to recognize it because we've seen it happening in a lower environment and we know how to respond to it appropriately, rather than seeing it for the first time or for maybe the second or third time realistically when we get to prod, and then being the Google DBA who goes out and is like, oh, why is my database slow? So hopefully this sparks a little bit of imagination for you and you're ready to explore how we run upgrades on Docker. So let's get started. So what do we need to do all of this? We need 3 images. And for clarity, in this next section, when I'm talking about source, I'm talking about the database that we're going to be upgrading from. We'll call it an 11G database. When I refer to the target, it's going to be the final destination. And I'll just say that it's a 19C database for argument's sake. So stepping back, and we're going to take a little bit of a wide view here of what our Docker image is going to look like. We're going to need 3 things. We're going to need a file system, And that file system is going to be a file system that will support our target database. And we're going to need two Oracle home directories, our source Oracle home and our target Oracle home. And first, we'll build out a file system with all of the binaries and the prerequisites for our target database version, because we need to have the appropriate libraries and dependencies established so that we're able to run our 19C database. Then we're going to add our source Oracle home database to that environment, then our target Oracle home, and then we're going to attach the target home to our Oracle inventory. So we're going to have a 19C file system with the 19C libraries and binaries and so forth, running a 12C Oracle home. And that 19C Oracle home is just going to be kind of sitting on the side as an accessory to begin with. So to accomplish this, we're going to take Oracle's GitHub repo files, and we're going to need to make a few changes to accommodate this, because this is not a straight out of the box thing that we're going to be doing. But it's really, there's not that much involved. Don't fret, don't worry about it. So the first thing that we need to look at is, if you don't already know this, if your target Oracle database is Oracle 18C or beyond, you're going to have to either remove or upgrade your Apex installation in that source database prior to running the upgrade itself. And if you run the Database Upgrade Assistant pre-upgrade jar, it's just a file that'll go through and it'll tell you, here are all the things that you need to do in order to upgrade to the next version. If you run that, you'll get a warning if you have this older Apex version in here, and it says you need to upgrade. And there's not a whole lot involved with removing up Apex if that's the most straightforward thing that we do. So we'll just change into that Apex directory, and then we remove this or run the script, and it removes our Apex installation for us. Awesome. That's great. Except if you do this in an Oracle image Docker container, you run into a problem. And that's because the script that installs Oracle into Docker, to build a Docker image, it removes a number of directories so that we're keeping the size of our final image down. And this is a pretty common thing for Docker images. We don't want to include a bunch of stuff that we're not going to necessarily need. Those things take up space. They'll increase our attack surface potentially. And the idea of containers is we want to maximize our infrastructure by keeping our images small. Small images run faster, they load faster, and so forth. So when Oracle goes and it says, what are the things that we don't need? Well, one of them is the Apex directory. So if you need the Apex directory to CD into and to run the script and it's not there, you can't remove Apex. So the first thing that we want to do is make Docker not delete that directory for us when we build the image. And that all takes place in the install dbbinaries.sh script. We'll go into that script and we'll just delete or comment out that line that removes the Apex directory. Then if you want, you can do a couple other things to add the auto upgrade. If you'd like, you can download auto upgrade and the latest database upgrade assistant tools from MetaLink. If you would like to have those, you can copy them into your Docker image. It's not necessary for you to do this. The Oracle 19C binaries include DBUA and the auto upgrade. So you don't have to do anything extra, but those versions are going to be older versions. So the latest and greatest is going to be available to you on MetaLink. So if you want to do that, you can certainly do that and copy them into the source image. Remember, we're creating two images here, a source image and a target image. And just copy those files into your Oracle base or your Oracle home. There's another file, another script file in the Oracle image builds in their GitHub repo that we want to look at. And that's this setup Linux env.sh file. And if you look, there's a version of this file for every database version, 12.2, 18.3, 19.3. And there you'll see that it is adding the pre-install or running the pre-install RPM for that particular version. And if we are starting out with a 12.1, 12c database, we're going to, from that image, get the 12CR1 or 12CR2 prerequisite install. We want to change that in the source image to this 19C or whatever our target version is going to be. And you're probably thinking, well, why do we need to do that? Because I'm going to be installing in this source image right down here. This is my source image, so it's going to be a 12C database. Remember, this is going to be the foundation that we're going to attach a 19C home to, and ultimately we'll be running the 19C database, so we need to have it compatible with 19C. While we're in the script, this is the script that does the yum install of things. There may be a few extra things that you want to include. Docker, as I mentioned before, tends to strip things down to the bare minimum. So there's no, in the Oracle images, there's no VI, there's no less, which are my particular editors of choice. So if you want to have an editor available to you, you can go into that yum install command that you'll find there, install whatever binaries you want. This file 5.1136 or whatever the current version is a prerequisite for the 19C install. So you'll want to include that as well. And then I do things like, if you've never worked with this tool called RLWrap, it gives you Linux-like navigation within SQL Plus and RMAN and so forth. It's a neat little tool, so I tend to add that. Then the next thing that you'll find is that the Oracle Docker images, at least the last I checked, are pluggable database only images. If you want to have a database that is non-pluggable or non-container, not multi-tenant, then just go into the response file. So every database version has its own response file. And you'll go into this dbca rsp.tmpl and just change true to false. I have a question here. How safe is it using RLWrap in a production environment? I've been using RLWrap in production environments for years and never had a problem. All that it's a wrapper that allows you to interact and gives you like a history sort of function like you would see in a bash shell. It just applies that to command line interfaces like SQL Plus and so forth. So I've never personally encountered a problem with that. So this is how you would convert your container database or your multi-tenant database to a non-container database, if you will. And then from there, we're just going to run the default build docker image.sh script as you normally would to create both your source image. Here we've got a 12.1 image. I'm sorry I said 11G earlier. I have my own set of repos and I have 11G builds in it. The 11G build in the Oracle repo is for standard or Express Edition only. So we'll say source version of 12.1. So when we're done running those two build commands, we'll have a 12.1 image and we'll have a 19x image as well, 19.3, 19.6, 19.9, whatever it may be. So now we've got two images. How do we upgrade this? We're going to use that copy command. Now remember, we were talking before, I mentioned that the copy command can be used to copy things from our local file system or from another image. And what we're going to do is we're going to use this image here, this 19.3 image. We're just going to pull the Oracle home out of that image and put it into that 12.1 image. And for that, we're going to have to create a brand new Docker file. You can copy an existing Docker file from one of the Oracle builds. This is going to be a really, really slimmed down version because we don't have to install a whole bunch of stuff. All we're really going to do is copy the image. We're just going to copy that 19C home from the 19C image into a 12C image. So you'll see that I'm doing this from command, and I'm referencing my source image. So I'm starting out with that. I'm going to add an environment variable for my target Oracle home. In this case, it's my 19C home. And then starting with this 12.1 image, I'm going to copy and I'm going to change ownership. And I'm going to tell Docker that I want to come from my target database image, and that I'm going to copy my target home from that old image, and I'm going to put it into the same directory, the target home directory, on my source image. And then I'm going to tell Docker that I want to run some commands as the root user. So I'm going to set my user to root here. And you'll see these commands are part of a normal Docker build. I'm going to add one additional root.sh, and that is for my 19C, or my target home directory. And the reason I need that is, you see when I copied it out of that target image, I told it I wanted to set the ownership of that directory. Here, I'll need to run that root.sh script one more time in order to set the ownership and permissions correctly. Then I run one more command. I'm going to tell it I'm going to switch to the Oracle user, and I'm going to run from my target home the universal installer's attach home script. And now this is going to go and it's going to discover my Oracle home inventory location, the pointer location, and it will attach the 19C home to my image. Now at that point, I'll have a 12.1 database image with all of my 19C binary prerequisites built into it. And then I'll have that 19C database home sort of tagging along as a little extra baggage or an accessory attached to that whole 12C image. Now I'm going to do one extra thing here. This is straight out of any of the Oracle images, setting the working directory, exposing a volume so that we can work with something. I'll explain this in just a few moments. You'll see this expose, which exposes a couple of ports. I typically add this 8080 port because auto upgrade has the ability to allow you to view its status via a web page. So we'll expose 8080 and we can run a simple web server in order to view that. I'll show that to you in just a few minutes. And then this sets the health check so we can see whether or not the container is healthy. And then this is a command that runs Oracle. So when we start the container, this command runs. It says, is there a database? If there is, it starts the database. If there isn't a database, then it builds the database for us. It runs the database configuration assistant. I have a question here. Is there a Docker image which mimics Exadata and its features? There is. It's restricted, but you can get some of the Exadata features by running a container, and in the container database, you can set, there's an undocumented, well, it's a documented, but it's an underscore parameter. It's underscore Exadata features, set Exadata features, something like that. If you enable that, then you'll get Exadata. So you can do things like run auto indexing and so forth, but you're not going to get the features of Smart Scan and cells and so forth. That's storage feature. So we have, this is the Docker file that we've created. Now we're going to run the Docker build command. And if you run it in the directory where the Docker file is, and the Docker file is called Docker file, you don't need to do anything else. You add this little dot, says running it in my local directory. We're going to give it this -t, says this is what I want to name the image. So I've named my image Oracle/database 12C-19C-EE, tells me it's Enterprise Edition 12C-19C. If you named your Docker file something else, then you just use this -f flag. So we'll build that image from that Docker file. And when it's all done, you're going to end up, when you run Docker images, you'll see this additional image And this is going to be where we can do all the magical, wonderful things of running upgrades. So you may be asking yourself, it seems like it would be much, much easier for me to just build a 12C image and then just copy my files into that 12C image, copy the 19C installer and then run the installer. And it is probably easier, and it's really obvious, and it's not at all a dumb question. The reason that we don't do it that way is that Docker uses something called union file systems. And with union file systems, the whole file system is purely read-only. And anytime you make a change to the file system, you create a new layer on top of that. And it tends to make container sizes grow rather large. By putting this all into a single image, pre-packaging it into the image, we keep the image size down, and we also improve the performance because we're changing less, so we don't have to read through multiple layers of a read-only or a union file system in order to find the correct version of a file. There is an easier way to do this if you'd like. I mentioned before that I have my own Docker repo, and I've got a whole bunch of stuff in here. So I've got image builds for 11.2.4 and then 19.6 through 19.9, builds container, non-container databases just straight out of the box. I do an awful lot of stuff with Docker, so I found that I needed to have something that was more malleable than going in and modifying scripts and so forth. I wanted to be able to pass all of this on the command line. It also supports data guard and sharding and all sorts of other things. If you're interested, there's the link. So now we have an image, and at this point we can run that image to be able to upgrade a database. An example of how we would run this image is just this simple, well, this isn't a simple Docker run command, but this is what I would consider maybe a minimally functional Docker run command. And if this is a little bit more complex than what you're used to, I'm just going to step you through this real quickly. So I'm going to run Docker run, and then this -d says I'm running it detached, so it'll run in the background for me. -v says that I want to map a file system on my local system. So this is just a directory that I've assigned, and I'm mapping that to the Oradata directory in the container. So anything that gets put into Oradata in the container is also, well, it's not also, but it will be preserved locally on my machine under this directory. I'm passing an environment variable with this -e. So I'm telling it I want my Oracle SID in this case to be UPG. And then these -p, these are both ways for me to map ports. So port 1521 in my container, I'm going to map it to 1921 on my local host. And port 8080 will be mapped to 1980. And so now if I want to see 1521 from my container, then I would look for it on my local host on 1921. I can give my container a name, and then this is the upgrade image that I used before. So once I run this, I'll be able to examine its logs, and I can also attach to the container, execute a bash, and have an interactive session where I can work with it. One thing that you don't want to do, I was mentioning volumes before, so I'm able to put the Oradata directory into a directory system on my own local machine. Notice that I gave it a name that was my container name here. If you were to just put it into this data directory and you had two containers running the same Oracle SID, all of those files would go into the same thing, and now you would have two containers that would both be using the same system01.dbf and same control files and so forth, and that's a bad thing. You don't want to do that. Maybe you do. I don't know. It's not for me to judge. All right, so we've got a database container running now. When that container first runs, the scripts are going to say, do I see a database? I don't. So it's going to create a 12C database for us, because this is at its heart a 12C image or source image. So it's going to run the database creation assistant, create our database for us, and then it's going to tell us the container or the database is ready and we can start doing things. And there are a couple of things that you may want to do at that point. Log into the container and maybe set some parameters in your system parameter files or your SP file. One of these is typically going to be the recovery file destination size. The Docker images, the recovery file destination size tends to be on the small side. And if I remember correctly, you normally want this to be around 20 or 22 gigs, something like that for auto upgrade and database upgrade assistant, so that it has enough room to work. You might also want to put your database into archive log mode. Docker images from Oracle's image repo by default are in no archive log mode, so you don't need to worry about them generating tons and tons of archive logs. You have to purposefully put them into archive log mode. This is something that you need to do if you want to use the database upgrade assistant, because it requires your database to be in archive log mode. I'm sorry, for auto upgrade, it has to be in archive log mode. Database upgrade assistant does not. Again, if you had mapped a port for 1521 and you wanted to be able to connect through SQL Developer, you can do that here. You just refer to that port that you used to map, and then your host is going to be localhost or whatever the machine name is if it's elsewhere in your network, and your service name is going to be just like it normally would, whatever service name you have defined there. Usually it's the SID in the Docker images. So I told you I was talking about auto upgrade. If you want to run auto upgrade, and I'll show you in just a moment here how that looks on running from a Docker container, you'll need to have a configuration file. And I have a whole separate presentation on auto upgrade, and Mike Dietrich has a wonderful blog site that he goes through all of the details, and it's a wealth of information on auto upgrade if you're not already familiar with it. The one thing you want to be sure of is that you're setting the upgrade node to whatever the container name is. This is a randomly generated hash value or host name that's created. So you just need to make sure that you're using that correct container name or container ID for your upgrade node. If you're running auto upgrade, you need to have Java installed, and you can run Java from your target Oracle home. It's the correct version, everything. It needs to be 1.7 or 1. I think it's 1.8 is the requirement. So if you just reference the target home's Java, then you can do all of the rest of this, and it's going to work perfectly for you. Now, I mentioned before that you can monitor auto upgrade over a web page, and I'm going to jump out here real quick. And this is a container database that I've been using to demonstrate auto upgrade for a couple of presentations. It's been running for like, it's been running since the, oh no, it's been aborted since the 27th. It's been running since maybe like the 23rd or so. So it's been around for a while. It's 90% or 94% done. I just stopped it so that you could see here's the status and so forth. What I'm going to do right now is I'm going to resume my auto upgrade job. And now if I go here, this is the web address. And I'm just going to be totally hands off. And if you just watch the screen there for a second, it's going to refresh. It refreshes every 30 seconds or so. And this is a really neat feature because if you have stakeholders in your organization that you want to give visibility into your, there it just changed. If you want to give those stakeholders visibility into the upgrade process, or just have them stop stopping by your cube or chatting with you every 5 minutes. What's the status? How's it going? This is a nice tool. It'll give you this percentage estimation as to how far along it is. So this is, like I said, a neat little tool, neat little feature. And you can enable that by just going into the config. I'm sorry, this is the wrong subdirectory here. So it's this auto upgrade /CFG-TOOLOGS/upgrade/auto. And then when you're there, you can just run the simple HTTP server. And then once that server is running, you can query or view that web page, that status page from anything on your network or from your local machine that has access to that host.
Question, you have 4 more minutes.
4 more minutes. All right, excellent. I can do that. All right, real quickly here. I mentioned before that Docker is going to put everything into that Aura data directory. It does something that's unique, and that is that it also puts all of your configuration files, all of your database configuration files, so your listener.aura and your password file and everything, it all goes into this subdirectory, this dbconfig subdirectory. And if we map that volume onto our local machine, like I had shown you before, then like right here with this -v command, then all of those files are going to be preserved in a local directory on your machine. And you could copy all of that out and you will have a gold image of your database. And where this comes in handy is that I can remove that directory if I want. So I can remove my container, I can remove that directory, I can copy that gold image back in place. I can rerun the same Docker run command, and it's going to find all of the data and all of my configuration, and it will restart the database right where it left off. I can also use this to clone my database. So I have gold image. Maybe this is something that you want to use for your QA team so that they have a reliable starting point for everything. And this is the procedure you would go through for cloning it. Just change the directory, change your ports that you're using, change the container name, everything else in your run command remains the same. You can also use this to generate snapshots. So if you are iterating through and you get to a step that always fails, you can snapshot at that step and not have to go through all of those preliminary operations. You can just come back to that particular problematic step and rerun it from there over and over again. This is real quickly some of the things that you can do within Docker for testing out and practicing your upgrades. I'm not going to go through them in too much detail here. Presentation slides are going to be available so you can review these at your leisure. But lots of neat things you can do. And what I want to really emphasize is being able to practice your upgrades. And that's because there are myths. People will say, oh, we have documentation that tells us how to do all of these things. But documentation doesn't address things like when things go wrong and people are standing over your shoulder asking you questions. People will say, oh, my database is under change control, so I don't need to worry about things. The older your database is, the more likely it is that something has sneaked past that change control. And finally, the last thing that I've done a lot of upgrades. There's never an upgrade that runs perfectly smoothly in production. There's always going to be something. It may be a big thing, it may be a little thing, but what Docker allows you to do is have that muscle memory built in because you've trained on it like an athlete. And now rather than having to think about what is this problem and how do I fix it, you respond to it and you react to it like an athlete would. And that's what we hope to gain here. So any additional questions now that I'm 20 seconds under?
Nope, looks like no extra questions, Sean, in this moment, but your session will be available for replay for 2 weeks in the conference website from today. And anyone is able to watch your session, replay as many times they want it. And if they have any questions, they can also add to the dedicated page for the replay a post, and you'll be notified that a question was made, and you'll be able to reply in our earliest convenience.
Perfect. And folks are always welcome to reach out to me through any of these means here, or any of these channels. I'm happy to talk and chat about Docker. It's my favorite. It's my little pet project. So thank you so much for having me and for attending the talk today. I appreciate it.
Thank you so much. Thanks so much, everyone. And please be safe, everyone. Thank you. Have a wonderful day or night for you. Bye-bye.